Say now we wanted to observe two variables, okay, or variables. Whereas in the previous example, we're just looking at one data set, okay, where we were working out the variance and the standard deviation. So now we want to be able to see if there's a relationship. If I'm observing two variables, is there a relationship between the two? So for example, if I was at EWC and I wanted to collect information on students and I wanted to see their attendance, all right, and their marks. So then my X variables would be how many days do they attend per term and what are the marks during that term. So that I want to see, is there a relationship here? Would I be able to see that the people who attend class more often, they perform better than the ones who don't attend? And this is what we call bivariate data, where you're looking at two sets of observations. All right. So how do we then measure this to see if there's indeed a correlation? Then we draw what we call a scatter plot. When you draw a scatter plot, okay, so you have your X values and your Y values. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Okay, there's a 9 there. Okay, 9. Okay, so then I plot the 2 points. So therefore at 9, I have 9, 7. Okay, so it can be like that, or you can put a dot there. Okay, then I have 5, 1, so 5, 1 lies here. Then I have 7, 6, which lies over there. Okay, then I have 3, 5, which lies somewhere there. And then I have 1, 3. Okay, so 1, 3. And I have another observation. So let's change this one and then say it's 2, 3. Okay. So when you're looking at this observation, actually let's change it to 3, 6. Okay, so 3, 6. So I have a 3 and a 6 there. Okay. So when you're looking at these points on your scatter plot, you can sort of intuitively see where the values are going, right? So they're sort of going in this upward direction, okay? And with that, you're actually then able to guess probably where, if X was 10, where would that point be? It would be probably, it'll be higher than 7. That's what you know, because you can see that as X increases, then Y also tends to go upward. So that's an estimation. So I would then draw my, my line to be something like that, perhaps. Okay. Intuitively, I can see that it's going upwards in that direction. Okay. So here I can see that there's sort of a correlation. So remember that example I was making, the number of students who are attending based on their marks. So if it's going this way, it's telling me there's a positive correlation, which therefore tells me that there's a relationship between the two values. So as the number of students, okay, so the number of days that they attend, then the performance actually then improves. So that's how you'll be able to draw conclusions when you're using a scatter plot. But now we're going to use what we call regression. And with regression now, we are able to actually determine what is this line here, instead of me just guessing what is this line of best fit, okay? And how do we then do that? We know that the line must be y is equals to a plus bx, okay? And with that, then it tells us how to find a, there's a formula for that, and how to find b, there's also a formula for that, all right? So let's just quickly write down the formula. So the first one is that b is equals to, let me just quickly find it. B is equals to n times e, okay, the sum of the x and the y, minus the sum of the x times the sum of the y values. All right, so let's just find space. So B is equals to the number of observations multiplied by the sum of the product of x times y minus the sum of the x values times the sum of the y values divided by n times the sum of the squared x values, all right, minus the square of the sum of the x values, all right, and a we know a to be, okay, the mean of y minus b times the mean of x. So which is why we normally work out b first in order then for us to be able to find the value of a. So here we actually then use a table. So right next to your x and your y, we then find these values that are required, okay? So here on the x's, what is required on the x's? On the x's, we need to know how many observations are there. So we know that n is equals to 1, 2, 3, 4, 5, 6. N is equals to 6. And we need to find the sum of those x's, all right? So 24 plus 4 is 28. So we know that the sum of the x values is 28, sorry. Then we need to find the mean. So the mean is going to be 28 divided by 6, which gives me 4,67. All right. The next one with my y's, it's the same thing. Okay, the sum of my y's is going to be 8, 14, 22, 28. It's the same. 8, 14, 22, okay, 28. So my n here is going to be 6, and my mean is going to be 4,67. So next we need to find my x times y. So x times y, we have 63. 9 times 7 is 63. 5 times 1 is 5. 7 times 6 is 42. 3 times 5 is 15. 1 times 3 is 3. And 3 times 6 is 18. So what do we need to have here? We need to have the sum of this Okay, product. So this here is 146. Okay, so we just about covered. Then we need to find which one now? We need to find x squared. So x squared, 9 squared is 81. 5 squared is 25. 7 squared is 49. 3 squared is 9. 1 squared is 1. Okay, 3 squared is also 9. So then we need to then find the sum, okay, of those x squareds. So this is equals to 174. Okay, and now our job is done. So now that I have all my values, I just need to substitute them back into my formula. Okay, so now let's continue finding B. So B is going to be 6 times, okay, this value here, the sum of my xy's, which is 146, okay, minus the sum of x, which is 28, multiplied by the sum of my y's, which is also 28. Okay, so all over 6 times the sum of my x squared, which is 174, okay, minus the square of the sum of my x's. So do you understand? So this is the sum of my x squareds, and this one here is the square of the sum of my x's. So then it's minus 28 squared. And with that, I'll be able to find my slope or my B value. So 6 times 146. Divided by so here I have B is equals to 0,35. And it makes sense for my slope to be positive. Remember when I was drawing it, it was upward sloping like that. On my scatter plot, I said my point, it looks like my line is actually going up. So it's a positive slope. So now how do I then find my A? So therefore A is going to be equals to my mean, okay, 4,67 of y minus 0,35, which is my B value, times 4,67, which is my mean of my x values. All right, so when I put that into my calculator, I get that A is equals to 3,04. Okay, so therefore my line of best fit is equals to 3,04 plus 0,35x. Okay, and then if I was asked to then draw that, I'm sure you should know how to draw a straight line graph by now. Okay, you can use the intercept method, where this one would be your y-intercept, and then when you make y equals to 0, you are able to solve for the x-intercept. You plot the 2 points, and then you join them with a line, and that should give you your line of best fit. So now let's say, for example, after you found your line of best fit, you are asked then to find the value of y if x is equals to 5. All right, so if x is equals to 5, then all you need to do is you substitute x is equals to 5 into your equation, 0.35 times 5, okay, so that you can find your y value. And there, when x is equals to 5, y is equals to 4.79.